stability of a conjugated system depends on the number of resonating structures that are getting formed. So, for example, if we have a structure A, B, C, and number of resonating structures for A is 2, B is 3, C is 4. So, the bond strength in C will be more. More is the number of resonating structures, more will be the strength of the bond. So, if a bond is strong, then what do you think? The bond will be longer or a shorter one? I think you will say the bond will be a short bond because atoms will be close to each other, so bond length will be less. So, stronger is the bond, lesser will be bond strength. Alright. So, what we spoke just now, we discussed just now was that number of resonating structure is more, then bond strength is more, bond length is less, right? So, bond length and number of resonating structures are inversely related, bond strength and resonating structures are directly related. All right. So, for example, we have taken few molecules over here. We have a propene molecule, then we have phenylmethane, then we have diphenylmethane, and the third one is triphenylmethane. As you see, the number of resonating structures is getting increased from 2 to 4, 4 to 7, 7 to 10. So, as the number of resonating structures is increasing, the bond strength is increasing. If bond strength is increasing, then stability of molecule as well increases. So, we can say the fourth molecule is most stable, then third, then second, then first, because the most stable is the one which is having maximum number of resonating structures. Since triphenylmethane has 10 resonating structures, it is the most stable, and the one which has the least number of resonating structure, that is least stable. Next, we come to effect known as mesomeric effect. So, mesomeric effect can be of two types. It can be positive mesomeric effect or negative mesomeric effect. Positive mesomeric effect is represented by plus m, and negative mesomeric effect is represented by minus m. So, plus m, how you decide whether a group has a plus m effect or a group has minus m effect, that I'll give you a small trick. All right. What you can do is, if you want to check whether a group of my atoms, or say for a species, shows plus m or minus m, just get it attached to a benzene ring or a conjugated system. So simplest is attach that group to a benzene ring. For example, if I want to check whether NH2 has plus m or minus m, I will attach NH2 to benzene ring. Alright. Now, since N has lone pair, it gives lone pair to the benzene ring. If a group of atom is giving lone pair to the benzene ring or the conjugated system, then the effect of that group is known as plus M effect. Similarly, if we so I'll give you a short trick. The trick is, if the atom attached to the benzene ring or any conjugated system for that matter has lone pair, this is called as lone pair. So, atom attached to the benzene ring has lone pair. Usually what you will get is, you will have either nitrogen or oxygen or halogen attached to the benzene ring, or any other conjugated system, that they will have lone pair, and their effect is always a positive mesomeric effect. Next, I'll take NO2. So, what is there in NO2? What do you say? Does it have a lone pair? I think your answer will be no. Nitrogen does not have lone pair in NO2, but it does have a pi bond. So, a group of atoms, if atom attached to the ring has pi bond, then it will show negative mesomeric effect or minus M effect. So, what are other examples of minus M effect are CHO, carboxylic group, COOH, cyanide, C triple N, aldehyde, we have already taken, we can take ketone group. Alright. Next, you can take ester group, you can take sulfonic acid group. So, these are groups which have atom attached to a pi bond. So, all these groups whatever I have taken up here are negative mesomeric effect showing groups, and any group which has lone pair, that will be. So, all these are examples of negative mesomeric effect. Similarly, if I show you OH, NH2, NHCOCH3, this is also written as NHAC. In short, COCH3 is also written as AC. AC means acetyl. So it is a short term for acetyl. Alright. So NHAC, all these have nitrogen which has lone pair, and this one has oxygen, and all halogens they have lone pair on them. So all these show positive mesomeric effect. What do you think about O minus? Does it show positive or negative? I think you will agree with me that it already has a negative charge. That means it is eager to give a lone pair to any conjugated system. So O negative will also have a positive mesomeric effect. So any atom or any ion which has lone pair, that will show positive mesomeric effect, and any atom or ion or a neutral group of atoms which has a pi bond attached to an atom, that shows negative mesomeric effect. Now, what will be the order of positive mesomeric effect? So, let me tell you that more is the electron density, more is the tendency to give electrons. For example, if you have O minus and O neutral, which one will give more electrons? I think you will agree with me. O minus will give more electrons. So, it will have a greater mesomeric effect, greater plus M effect than a neutral O. Alright. So, O minus has greater mesomeric effect than OH or OR. Next, what do you think? NH2 will show greater mesomeric effect or OH? I think you will say N has less electronegativity, so it has a tendency to share more electrons than OH, which has oxygen donating atom and it has more electronegativity. So what will be the order? Order will be O minus, then you will have NH2, then you will have OH, then you will have OR, then you will have NHAC. So this will be the order of positive mesomeric effect. So I hope it was helpful for you. Thank you.